So welcome to week 7 of the practical programming part of the software training, also known as the last part of the software training. And so here we're just going to cover some advanced C++ stuff, slightly advanced. Some more things in the standard library, which are fairly useful. So first we're going to be talking about lambdas. So what are lambdas, besides being a Greek letter? They're basically a function that you create one time to pass as an argument to another function so that that function can use the functions. It's a bit complicated. An example would be the sort function. So with a sort, you give it an array to sort, and then you also give it a sorting function. And that function takes in 2 arguments and returns a Boolean value depending on if they're in the correct order or not. And so for most of the things, it's just a simple compare of less than. But if you're doing a more complicated object, then you might want to have your own custom sorting function. And so that's where lambdas come in handy. There's a bunch of other useful cases with lambdas. So here's the anatomy of a lambda function. So you have a capture clause, a parameter list, the mutable specification, the exception specification, the trailing return type, and the body. We will not be covering I don't think we're covering the exception stuff because exceptions are scary. I wrote this a long time ago. So the capture clause. So the capture clause is basically a way to define which variables a lambda can manipulate. So here we have these 2 variables, G or GA and GB. So they're global. And so we want to be able to access them to, we want some of these lambda functions to use them. And so here, there's this f lambda has no capture, so it can't access any of these variables. Here, because we have GA in this bracket, we can access the value of GA. So this lambda would just return whatever GA equals. Here you can capture by reference. And so this means that you can actually manipulate the variable outside of the scope. So here the ampersand is the same as in regular functions where it's like the address of, and so it means that you can manipulate it outside. This equal sign means that basically any global variables, we can look at them. So you can access both GA and GB. And then this, just the ampersand means that you capture all of the global variables by reference. So you can manipulate all of them. Usually you're not going to be dealing with much in the way of like capture clauses, but it's useful to know in case you want to be able to look at data outside of the Lambda function scope. Next, there's the parameter list. So after the capture clause, you can have the parameter list, and it's basically the parameter list of a regular function. It's the type and then the parameter name. And so sometimes if like with a sorting function, you might have multiple possible types that you're dealing with. And so with the C++ 14 version and above, you can just use auto. So like if you have, so say you're just dealing with generic numbers, like ints, longs, floats, and doubles, and you don't want to make a lambda for each specific like comparison possibility, which would be like 16 different ones, you can just use auto. So possibly useful. Again, parameter list is just like a normal functions parameter list. Mutable. So if you use the mutable, then the lambda will be able to modify the variable captured by value, but only the copy. So this basically means that we create a copy of the GA and we're actually able to change it. And this is unlike reference because it does not actually affect the GA outside of it. And so I forgot to mention earlier with capture clauses, but when you are capturing something, you cannot modify. When you're capturing by value, you can't modify its value. Like even the internal scope copy of it, you can't modify it. So if you have mutable, then that means that you can manipulate the copy's value. And so this is just a simple execution where we're just summing up values of a GA and decrementing it so that we get like the triangle number, something like that. This is just a way to show that you can manipulate GA. And then the trailing return type is like a regular function's return type. It's just what's the type that the function returns. And unlike a regular function, it does not come at the beginning, it comes at the end, hence the name trailing. And the thing with Lambda functions is that it's not required what the trailing return type is unless you have multiple return statements, in which case you need to specify what the type is. So here you see, because there's just the single return, we don't necessarily need the specification that returns an int. But if we have multiple return types, then we have to specify it's an int. All right. All right, and that's it for lambdas. I hope you got all that. But yeah. Next, we're on to standard containers. And containers are ways to handle the storage of primitives or objects. So you've already probably been familiar with standard vector. There's a whole lot of other ones, so we'll just cover those. First is the vector you all know and love. It's dynamically sized, so you can add and remove, and it doesn't throw a fit. And its template means that you specify what type it contains. And so here you just say, when you're constructing the vector, you have to specify, I contain this type of object. And so inside these alligator brackets, it's like a standard colon vector, standard colon vector, alligator brackets, type name. And that's like the type of vector that you're dealing with. Next is an array, which is a fixed length storage container. And so it's the length can't change, but it also is a bit more efficient with like finding values and such, because it doesn't have to worry about being potentially infinite length. And so you have to specify what type the array is holding, but also the number of elements it contains. So here's where you define that it is a fixed length. Then there is what's called a stack. So like you might have heard, the stack in regards to like computer science before. That's like a separate pseudo-related thing, but a stack object is a LIFO container. And so what LIFO is last in, first out. And that means that the last item that you insert onto the stack is the first one that will be taken out of the stack when you use the remove function. And so it acts like an actual physical stack of objects. You put stacks of things onto, something, and then you remove the top one, and then the next one becomes the top one, and you remove that, and you keep going, and you might add on and then remove and stuff. And so, yeah, the last one you add, the first one out. And again, you template what class it is, and Jason didn't finish this slide. Important methods, I can just say there's, I'm pretty sure it's just called add, insert maybe. You just add, and that just puts it at the top of the stack. And then pop, I believe is the name. Pop is the one that takes it off and returns it. So yeah, so you just, two main functions are add to the stack and remove from the stack. A queue is a FIFO, so first in, first out. And so it acts like, the queue to, you're standing at a restaurant waiting in line to order your food. The first person that got into that line is going to be the first one to order their stuff. I don't know. Real world example. You get it. And so it's, again, dynamically sized. You can have as many people in that line as possible. And again, you template it and you say, this contains whatever object. Then there's the more complicated example called a priority queue. And so a priority queue is an order of elements that is sorted based on some variable. So you have to decide what variable is the thing, or like what method is used to give the objects in this queue some priority. So again, dynamically sized, you can have whatever many objects in it. Again, you have to say what type is it holding. You have to give it a container type. So you have to say what's the type of container that is actually holding all of these units, and then you have to give it a compare function. So you have to say, you have to give it some sort of function that returns true if A goes before B and false if B goes before A. Lambda stuff sort of coming in here, where you would, have some function which just says, if this certain member variable is less than this one's other member variable, then return true. So this is basically a way to have a sorted list that you can pop off the highest priority at any given point. Next is a list, which is just a linked list implementation. That was one of the exercises, and a linked list is basically you have a series of what are called nodes, and each node contains a bit of information and points to another node, and then that node points to another node until you reach the end, in which it points to null. So that means there's nothing left, and so it's dynamically allocated, and you tell it what type it contains. Then there is a set. A set is unique in that all of its elements must be unique. It's dynamically sized. You tell it what is the class it contains, and then you give it a function called compare, which basically tells it how to know if two objects inside of it are the same. So it won't let you add something which already exists inside of the set. And you tell it how to do that using the compare function. Then there is a map. And so a map, the keys in the map are a set. So you can't have the same key. And so I'm pretty sure how it works is that you have a set of keys, and each of those keys has a object that it unlocks basically. And so you have the set of keys, and so you have to say what type is the key, what is the type those keys hold, and then how the compare function before, so how to tell if the keys are the same. And so the yeah sorry, Jason here. Can Jason explain this a bit better than I can? He is not. But yeah, it's an unordered map and unordered set are often preferable. Yeah, like if you don't need to care about order. Kyle, you were gonna say something.
If you've heard of like a hash map or a hash set, probably just hash map. Unordered map is a hash map. Regular map is like a tree. It's like a binary tree. It's a small distinction, but it means that unordered map is going to be a lot faster for a lot of the regular applications that you're using. So if you're just trying to use a dictionary, like like you'd have it in a lot of other languages, usually you'd want to use unordered map.
Yeah. And so an example where you might want to use a map is like a basic level. It's like sort of a password system. So like the keys would be like the passwords put through a hash or something. So like a hash map. And then the key would be the way that you access the user info. And so it's a way to sort of create an array where the indexes are all unique and have intrinsic information about them. So that's where you'd use a map. And here's the slide that talks about the thing that Kyle just talked about. So unordered. No, I don't know about this anyway. So unordered containers, unordered, not ordered. Yes. So there's unordered sets and maps, constant time access. You use unordered. Yes. Cool. Good. Algorithms. So algorithms are a bunch of methods that you can call on these collection classes, and they either return a value or change the structure, but they can't do both. First, there's reverse. And so reverse does what you'd expect. It reverses a certain section of a container. And so here's where we introduce the concept of iterators. And iterators are basically a pseudo class which describes like a way to iterate over whatever container you're doing. And so you have this start iterator and end iterator. And so this is basically a way of saying, here's when I want to start reversing, and here's when I want to stop reversing. And this brackets basically means that it's inclusive of the start. So whatever iterator you give it, it will say, all right, we're going to reverse with this one, but it won't reverse with the last one. So the last one will remain unaffected. But usually, I believe this is the case, usually like the end iterator of like, if you ask like a container, like give me your last iterator, it's actually like beyond the last object in that list, so that if you call reverse and you, because usually containers have something called a .begin and .end, and those are the first and last iterators of that container. And so if you call reverse container.begin, container.end, that will reverse the entire list. So yeah, just remember that the last one is unaffected, basically. Okay.
Yeah, so I mean, if you a good like mental model for these is indices into an array, right? So if you have a vector with like n components, the dot begin is just going to be at index 0, and dot end is going to be index n. Sorry, index n. And remember that because your last index is n minus 1, that dot end iterator is that's sort of the model that you need to think about, where it's one past the end.
Yeah. All right. Then we have count. So we have reverse works in place. Yes, it will reverse the whatever container you're doing. It won't return a reversed container. It will actually manipulate the data. So yeah. Then there is count. And again, inclusive at the start, exclusive at the end, and counts the elements that are equal to the one that is passed in. So you indicate when you're starting, you'll indicate when it's ending, and then you have this value that you are wanting to count. And so you want to count how many, say you just want to count how many zeros are in this array. You would do begin, end, 0, and that will return the number of zeros. And again, because this returns a value, it does not manipulate the data. Then there's count if, and it searches the container, and instead of it just being equal to some value, you actually pass in a lambda function. And so this lambda function takes in a singular value, and it returns true if it's like, yes, this is a thing we count, or false if it's no. So there's counting with basic like equivalence, and then there's counting with a more specific lambda function. Then there's find, and this returns the I believe it's like, it would have to be like the address or something. It returns the first object that matches the object that you pass in. So it does that, and then there's find if, which is similar to count if, which is the count of whatever, or find if returns the first object, which makes the lambda function you pass in return true. Simple, understandable. Yes. Then there is for each. You might have heard of a for each loop before, but this is a way to apply a function to each stored variable, and then change that value to whatever change that value depending on whatever lambda you give it. So you might want to say you have a vector of just positive and negative integers, and you want to absolute value every single one of them. You would use for each, and then just return the absolute value of the input given, and that would make all the numbers in that vector positive. Then there's sort. It's the one I mentioned at the very beginning. It's you give it a start and an end, and then a comparator lambda, and that comparator lambda is the way to say this one is less than this one, and then it does some sorting algorithm. Does it use like a specific sorting algorithm, or is it just a bubble sort? I would guess it's bubble sort, but
sort. I think it's a variant of quicksort,
that
but
would
it's
make
not.
sense.
It's definitely not standards defined, but I think everyone uses a variant. I think it's like called Tim sort or something. It's a very
Tim
fast.
sort.
I think it was made by a guy named, I think it's called Tim sort. It's named after someone, and it's a very generic name. Yeah. Okay. Yeah.
Imagine naming a sort after yourself.
I'm pretty sure it's Tim sort.
It's not like an acronym of like TIM or something.
A guy named Tim. As far as I remember, it's been a while, but
some
yeah.
guy named Tim optimized the hell out of merge sort, so it's merge sort actually.
Merge sort or quick. Whatever. It's irrelevant. It's technically not standards defined, but the answer is that every real implementation is Tim sort.
Cool. So yeah, that's standard sort. And there's a whole lot of algorithms because basically there's a lot of ways that you would want to manipulate containers. And so there's if you just look at the CPP reference website and search algorithm, you will just find all of them. And there's a lot. So if you ever find yourself thinking, I want to do this to some container, just search and see if there's an algorithm for it already, because somebody's done it and somebody's done it better than you can. So that's programming, baby. Congratulations, you've been through training. That's all. Congratulations. Clap. Everyone celebrate.